Multi-hop questions break retrieval. Ask an AI who founded the company that acquired the startup that built the model behind your favorite chatbot, and most RAG systems fall apart. They retrieve one chunk, then let the language model plan its next step on the fly, and that is exactly where it all goes wrong. A 2026 paper from Shanghai Jiao Tong University called RT-RAG, Reasoning in Trees, fixes the structure first. The result? It beats 12 strong baselines on every single benchmark cell. The trick is something almost every RAG system gets backwards. Here is the failure. Self-guided iterative RAG lets the model decide each next retrieval from its running context. Two things break. Reasoning drift, where one early wrong answer contaminates every retrieval that follows, and query decomposition error, where the question gets split in a way that does not match the true dependency structure. The paper's example, asked about the author Felix Salten, self-ask, confuses his birthplace with his home city, chases irrelevant book titles, and returns the wrong answer. Replanning every step is what lets one mistake cascade into a completely wrong answer. The thesis of RT-RAG is, fix the structure first. It pre-decomposes the question into an explicit reasoning tree, T equals V and E, where nodes are subquestions and edges are answer dependencies. Build it once. Then validate it by consensus, generating 5 candidate trees and picking the most frequent shape. Retrieval then runs as a bottom-up post-order traversal. Leaves get answered directly. Parents combine their children's answers, and if a child returns none because the evidence is missing, the parent converts into a new leaf. The tree cannot drift because the structure is locked before any retrieval happens, and the numbers are decisive. On 3 multi-hop benchmarks, MuSiQ, 2 WikiMQA, and HotPotQA, RT-RAG leads every single cell, both models, both metrics. With GPT-4o Mini, it scores 64.9 average F1, beating LongRAG's 57.3 by 7.5 points. With the OpenQuinn 2.5 14B, it hits 63.3, nearly 10 points ahead of LongRAG. The open model with structure edges the closed model without it. Structure buys a weaker backbone more than retrieval tuning buys a stronger one. Where does the gain come from? Tree depth. Going from flat depth 1 retrieval to a depth 2 tree is the single biggest jump. On 2 WikiMQA, F1 climbs from 58 to 73, a 15-point gain and 1 level of decomposition. Depth 3 and 4 add almost nothing. The paper itself calls depth 3 the optimal balance. So the win is not deep recursive reasoning. It is 1 or 2 layers of dependency-aware decomposition and then diminishing returns. Most of the lift is free at depth 2. Picture the difference. Self-guided RAG is a tangled root system. Every retrieval spawns new shoots in random directions, and wrong roots feed wrong branches downstream. RT-RAG is a clean tree. 1 trunk, deliberate branches, each leaf a question with one answer that feeds its parent. When a leaf is missing, the tree reroutes around it instead of dying. That graceful reconfiguration is the robustness mechanism. The structure is the product, and every component pulls its weight. The ablation on Quinn tells you which pieces matter. Remove query rewriting, the synonym expansion when retrieval fails, and you lose the most, 2.1 average F1. Remove consensus tree selection, lose 1.8, rejection sampling, 1.7. Structural analysis, 1.6. Nothing is dead weight. Query rewriting is the biggest lever because it is what rescues retrieval when the first phrasing misses the evidence entirely, so the recipe is this. Decompose once, by consensus. Traverse bottom up, rewrite queries on failure, resample answers and keep the majority, and convert missing leaves instead of giving up. The one move that matters most is structure first. Stop letting the language model replan every retrieval step. Lock the dependency tree before the first chunk comes back, and drift becomes impossible by construction. RT-RAG beats 12 baselines across 3 benchmarks, with an open model matching a closed one, all from a reasoning tree. The paper is Reasoning in Trees, published at www.26, code linked below. The lesson generalizes. When multi-hop retrieval drifts, the fix is not a bigger model or more context, it is structure. Subscribe for the next paper breakdown.